So my question for you, if 3 to the negative first is 1/3 and 2 to the negative first is 1/2, what is 3 to the negative first plus 2 to the negative first?
1/3.
It is 1/3 plus 1/2, which is the same thing as 5/6. It is not the same thing as 1/5, right? It doesn't mean that I take 1 and I put it over 3 plus 2, which makes it 1/5. You don't just move these down as one fraction with the denominator being that sum. So what we want to look at next are problems that look like this. I have confidence in you that you can get this. So we look at this right here, and I cannot, the negative, you guys look at those exponents and you say, well, they're all negative, so I'm just going to flip them. And this is what I see that is incorrect. People just want to do this, x over y, x squared plus y squared, and you're done. You can't, because there's a term right there, which makes this like that 3 to the negative first plus 2 to the negative first. That is not the same thing as just 1/5. You can't just move them down. Yes, Wilson?
So what would you do if x was the negative first? You put that up there, but how would you put it in the fraction?
We're going to show this as a complex fraction. So the first thing we want to do is we just want to focus on just this numerator part, writing them as positive exponents. So you get 1 over x squared plus 1 over y squared. I just wrote it, the numerator with positive exponents. Now focus on the denominator and write that as a positive exponent, 1 over xy. Now you get this complex fraction that doesn't look any better. It actually looks worse because you got all these fraction bars than what you started out with, right? Because I think most of us would rather look at a negative exponent than fractions. But if I were to look at this problem that I have, we want to focus on the numerator. How can I make that one fraction? Because if it's one fraction divided by another fraction, then I can just flip the denominator 1 and multiply them together. If I just gave you this, all I did was just look at that denominator right there. If I covered this up and just look at that, it's a negative exponent, so I just move the negative exponent to the denominator. Eventually, we're going to get it into the numerator because we're going to divide by that. You can, I will tell you this much right now. They want you to get practice with complex fractions. If you really wanted to, one way you could solve this, I'll show you what you're, okay. There's another way you can solve it, but the way they want your answer, you're going to have to do an additional step than what you're used to. Okay? The first thing they want you to do with this is just take each term and write it as positive exponents. Complex fractions is what they're trying to give you practice with. So you've made it a complex fraction. Now what you want to do is you want to write this with a common denominator. So I have to multiply by y squared for the first fraction, x squared for the second fraction. So you get y squared plus x squared over x squared y squared. And what you're doing to that is you are dividing it by 1 over xy. How do you divide fractions? Keep, change, flip. So I'm going to keep the red, I'm going to change it to multiplication, and I'm going to flip this, which makes it xy over 1. There's where your xy into the numerator comes from, Wilson. Does anything cancel right there? Yes. You can't cancel with terms, but you can cancel factors. So this xy cancels with one of them there. This y will cancel with one of them there. So you end up with y squared plus x squared over xy.
Can we cancel that out?
You cannot because it's terms. So if I told you 3, you can't because it's terms. I could put numbers in there showing that, but
Wait, could you take one out of the numerator?
nope. It has to be as factors. And because these are separate, you cannot. These are separate terms, so you cannot cancel. If you could factor, if there was another x here, if it looked like this, if it looked like that, what you could do is factor in x out of the numerator, which leaves you with y squared plus x, right? Because if you distribute that back through, you get that, divided by xy. Now this is a factor of everything, so now that x would cancel. But that's the only way you can. It has to be in every single term in the numerator in order to cancel with the denominator. Has to be that way. There's your answer. Wilson, your question. Given this problem, I think what Wilson was implying is you have this one, this is factors. It's a product. If it's a product, not a sum, you can move it up and make it positive. Yeah, that looks like an easier problem. You have xy times the quantity. Sorry, that's not the problem. That's the problem. So it looks like an easier problem. All you have to do is the distributive property, right? If you use the distributive property, you're going to get x to the negative first y plus x y to the negative first. It's okay if you want to do that, but from there, for some professors or something, that could be an answer that they want. What your book is wanting, though, is for you to write that as positive exponents and then go ahead and get a common denominator. And your answer becomes y squared plus x squared over xy. Now, the way we worked through that before, we ended up with y squared plus x squared over xy.
Which way would you prefer that we do it?
I know what they're trying to make you do, and that's get practice with complex fractions, which will be beneficial to you when you get to other types of problems, is understanding this process. And that's what they're wanting you to do, is get to the understanding of this process right here. If there was a plus sign right here, you would not be able to do that second method, because you can't do it when there's a term in the denominator like that. There's something else you have to do. So they're wanting you to get practice with this method, is what they're wanting you to do. But just like math, is there another way to get to the solution? Yes, there is. Have a good day.